Hi everyone, today we're going to look at solving multi-step inequalities. Our process to solve multi-step inequalities is really no different than solving a multi-step equation. I still break it down to a two-part process. The first part is to simplify, and when we simplify, we distribute and combine like terms. Then the third part is our solve mode. Alright, so let's just go to the one key difference between solving an equation and solving an inequality. When we're solving an inequality, anytime you multiply or divide by a negative number, we have to make sure that we flip the inequality sign. And that's usually in our last step. Alright, so let's take a look at this first example. So we have this 1/2 that we're supposed to distribute, and that's something that we've always talked about doing, distribute that 1/2. But remember, sometimes fractions aren't as easy to deal with. So another way that we can look at this, instead of multiplying by 1/2, we could instead cross this off, and instead of multiplying by 1/2, I can divide those two pieces by 2. So once I've done that, I am down to this. So now I've got my x divided by 2 minus 2. 4 divided by 2 is 2, and I brought down my less than -1. Alright, now from there, I can finish solving this. So in order to do that, I need to isolate my term that has the variable. That's this term right here. So to do that, I'm going to add 2 to both sides. And when I do that, I always like to draw my line. I get to cancel those out. And then we're down to x over 2 is less than 1. Now, to finish solving this, we have to undo this divide by 2, so we're going to multiply both sides by 2, and we have x is less than 2. Those cancel out, which is why we only have x left over. And then that's our final answer. Now we can graph it. So I need all the values that are less than 2. So I'm going to come over to my number line. And I think your number line actually has all the numbers on it, but you're going to put it, in this case, an open circle over the 2, because it's just less than. I'm not including 2, it's not equal to 2, so it's an open circle. And then all my numbers that are less than 2 are to the left. So less than, left. So I draw a line to the left. Alright, now I want you to try this next question on your own. Same type of problem, try on your own. Don't forget, when you're distributing by that negative number, what happens here. Okay? And then don't forget that process at the very end, when you have to divide by a negative number. Make sure you flip your inequality sign. All right, go ahead and pause your video now. All right, let's take a look at the next example. All right, this time I don't have anything to distribute, but I do have some like terms. So I'm going to start by just drawing my line. I don't have anything to distribute, but I do need to combine those like terms. So if you still want to continue using that process of splitting it up into two parts, like this, I've got my variables and my constants. I'm only simplifying the left side right now. Okay? So I have each of my separate terms. So if you want, you can box up each of your terms. Sometimes that does make it a little bit easier to look at. So now my x terms was the 9x and the 1x, the plus 1x. My constant terms were the 13 and then minus 1. So now I'm going to combine those together. I end up with 9x plus x is 10x. 13 minus 1 gives me a positive 12. And I bring down my less than or equals to 72. Now I can isolate this guy here, so I'm going to do that by subtracting 12 to both sides. These cancel out. And now we have 10x is less than or equal to 60. All right, now to split the 10 from the x, I'm going to divide both sides by 10. That cancels out these 10s. And now I'm left with x is less than or equal to 6. So now I can come over here and I can graph that. All right, now this time it's got that equal to, which means I'm going to include 6 as part of my solution. So I'm going to put a closed circle over the 6. So I'll put my closed circle over the 6. And then once again, it's less than. So we have to make sure we highlight all the values that are less than 6. Those are all the values then that are going to be to the left of 6. So my graph would look like that. And let's go to the next page. All right, I want you to take this problem and I want you to try this one on your own. Go ahead and pause the video now. Okay, 2 more examples and then 2 more try on your own and we're done. All right, so let's take a look at this one here. So first we're going to distribute, and then if we have like terms, we'll combine those. So in this case, I've got a 5 and I've got a 2. The 2 is the number I'm going to distribute because that's the one that's actually stuck to the parentheses. So I'm going to take that 2. First I'm going to bring my 5 down. I'm going to take the 2, multiply it to the x to give me 2x, and then 2 times 1 is 2. So we end up with 5 plus 2x plus 2 is greater than or equal to 23. All right, now I can combine my like terms. Again, if you want to use that concept of splitting it and having your variables and your constants, you can do that. I can also just do that step in my head. So I'm going to box up each of my terms. I'm going to only look at the left side, just my left side in this case. So when we look at the left side, my like terms are the constants, the 5 and the plus 2. The 2x is by himself as a variable term, so I'm only going to combine my 5 and the 2. When I do that, I get 2x plus 7 greater than or equal to 23. I need to isolate my variable term, so I'm going to move that 7 over with the 23 by subtracting 7 on both sides. And when I do that, my 7's will cancel out. And then we have 2x is greater than or equal to 16. Can divide both sides by 2. And now we're left with x is greater than or equal to 8. Right, so now when we go to graph that, I'm going to have a closed circle over the 8 because it's got that equal to part. So I'm going to put my closed circle over 8, and this time I need all the values that are greater than 8. So numbers that are greater than 8 are going to be to the right of 8. So now I draw my line to the right. And there's my graph. All right, let's do one more together. All right, this one here, we have that 3x and then a minus sign. What we're really looking for is a number that is stuck to the outside of the parentheses. Since I don't see a number, I'm going to put a 1 there. So what I'm really distributing here is that negative 1. So my 19 comes down, greater than or equal to 3x. I'm going to distribute the negative 1 times x, and then the negative 1 times negative 7. Remember, if this is negative, it's going to change this guy to his opposite. So I end up with 19 is greater than or equal to 3x minus 1x plus 7. Negative 1 times negative 7 is a positive 7. All right, let's take a look at our like terms. Because we do, have some like terms here. And again, like terms are always on the same side. So in this case, my like terms are the 3x and the 1x. So I have 3x minus 1x will give me 2x. Bring down my plus 7. Now I need to isolate my variable term. So I'm going to subtract 7 from both sides. When I do that, it cancels these guys out. And then I'm left with 12 is greater than or equal to 2x. Now I can divide both sides by 2. And then 12 divided by 2 is 6. So I get 6 is greater than or equal to x. And we can't leave it that way though. We have to flip that around so that the x is on the left side. So when we do that, we also have to flip the inequality sign. It's pointing to the x right now, or we can look at it as being open to the 6. So when we go to flip our answer around, I still need my inequality sign to point to the x, or be open to the 6. So when I flip this around, I also have to flip that inequality sign around. So now I'm looking for all the values that are less than or equal to 6. So I can graph that. Because it's or equal to, I'm going to start with an open circle. And then all my values that are less than 6 are all going to be to the left of 6. So graph it this way. Okay. You have 2 more problems to try on your own, and then we will be done, and I'll see you in class next time.